my research group at the University of Manitoba in the Department of Chemistry, we mainly focus on interchromophore interactions. So chromophores are molecules that absorb light or interact with light in interesting ways. And so we are mainly focused on soft materials and liquids. The ultimate dream of our lab would be to take materials like brittle, hard solar cells and turn them into paintable liquids. We imagine a world where you could buy a can of a solar cell, simply paint a wall, and turn this into a functional solar harvesting cell. So currently we are working on the synthesis of a series of different chromophores. So a series of 12 different molecules which have only tiny structural changes. And these tiny structural changes bring about large changes in their interaction with light. And so we're studying this series to see if we can glean some foundational knowledge to push us towards our goal. With the Research Manitoba Grant, we're building a new series of molecules with a special chromophore that allows us to very precisely tell how these chromophores are interacting with each other. So when we have two molecules, they can become very close together and interact strongly, or they can be very far apart and interact not at all. We are trying to find new ways to sort of find a middle ground, where even at maximum density, when these molecules are very close to each other, they still act as if they're completely isolated. The research that's going on here in the Department of Chemistry in my lab directly affects Manitoba and Manitobans. We are building foundational knowledge. We're trying to make completely new materials for the future, but we're also training students and researchers in organic synthesis, in materials characterization, and rheology. So all of these skills have direct overlap with Manitoba's strengths in manufacturing, in the polymer industry, in the energy sector, and petroleum. So with this grant, we're looking to attack modern problems in materials science. And many of you are probably familiar with new phones with foldable screens. These are produced using polymers. And while the polymer chemistry has come so far that these screens can be folded hundreds of thousands of times, for certain applications, somewhat surprisingly, this is insufficient. So the advantage of liquid materials like we are making is that they can be folded indefinitely with no change to their physical properties. The research that we're doing here also has a significant sustainability impact, where traditional materials, traditional organic chromophores need to be dissolved using chlorinated solvents, and then a huge amount of energy needs to be applied to remove these solvents. Our materials, while being rendered liquids, can be doped with all sorts of additives without using solvent, minimizing the environmental impact of solar cell manufacturing.